Okay, is everyone there? Okay, just let me know when you're ready. We'll start. um, okay, the way this YouTube live works is you can actually rewind or fast forward depending on how fast you learn. I'm gonna turn off the sound because it's actually kind of confusing me at the moment. So you can see my desktop and you can see me. Well, you can't see me, you can see my desktop, and we're gonna start. Okay, a lot of students, when they spoke to me earlier in the week, they actually mentioned that between lesson 1 and lesson 2, they were actually quite confused with a lot of things. So in the interest of things, I'm going to be working from the ground up. Okay, so you see, this is my screen. It's going to be fun now. I'm going to go to Jupyter Notebook. Moderators, just help text me in case the students don't follow. I can't see the chat on the screen at the same time, so I'm just going to keep going until I have a question. Okay. Okay. I'm going to go to development and I'm going to go to class. This is Jupyter Notebook, by the way. If you're not familiar with it, the way it works is you go to Anaconda Navigator, you launch the notebook by clicking the launch button, and it actually brings you to this page. Okay. I'm going to create a new Python 3 notebook, and I'm going to call this Makeup Class 2. Okay. So now we have the open editor. I'm going to go everything from the ground up. So the first thing I want to talk about is variables. In primary school, you probably heard of algebra. Algebra being, for instance, y is equal to x plus 2, or you've heard of y is equal to 5 plus 7. These kind of expressions are what we know as algebraic expressions. In computer science, these statements mean slightly different things. So in algebra, you're probably used to seeing these two statements, right? You see that y is equal to 5 plus 7 is equal to 12. And you can deduce from here that x is equal to 10, right? Because if y is equal to 12, then 1 minus 2 is equal to 10, x is equal to 10. In programming, if you try to run this code, it will actually give you an error. It actually gives you the error x line. And that's because in programming, you need to do a few things. So let's get rid of this. And I'm going to write a line on top. I don't want you to get confused, but I'm going to explain as I go along. So I'm going to say int x, right? X is equal to 15. Y is equal to x plus 5. And I'm going to print y is equal to y. And x is equal to x. Okay, and I'm going to run this. And it's going to show me both the values of x and y. So the way a computer program does is it creates like a box, okay? Creates a box labeled X and assigns it the type integer. Okay, we're going to go through types later on, so don't get confused. Okay, then if I take the value 15, which is an integer, I'm going to put 15 inside the X box. Okay, we're going to assign integer Y. Okay, and same thing as the X for consistency. And then what it does here is it evaluates the right-hand side of the formula, the X plus 5. It's going to determine the value of X as 15, and it's going to add 5 to that and assign the total to Y. So what's going on here? In computer programming, we have two expressions when it comes to assignment. We have what's known as the left-hand side of the equation and the right-hand side. Okay, the right-hand side always gets computed first. Okay, so you can just as easily leave out these expressions. You can just say 15 and X plus 5, and these are valid statements in computer science in programming. But the problem is you're not assigning it anything. So these are pretty useless values. So we assign it to these two boxes, box X and box Y. Okay? And so those are variables in a nutshell. Now, going back to types, okay, we talked about type of integer, all right? And you have type floats and type strings. And so this gets quite confusing, and I like to use an analogy. So a long time ago in high school, we was in a French class. And in my French class, there was a Canadian international student who came to our class, right? And basically, he was brand new. He was from Quebec. So in Quebec, they speak French. They speak a different dialect of French. And my French teacher was from France, right? So we spoke different dialects. There was different accents, saying things. And I remember once my teacher gave us says, I want you to turn to the person next to you. Et je veux que vous embrassez, right? It's a statement. It means I want for you to embrace the other person. Like give him a hug. Okay, it's a weird class. So the Canadian student actually got really upset by this. Went to the principal and said, I don't appreciate your teacher saying these kind of things. And what it means by that is in Canada, when you say je veux t'embrasser, it means I want to I want to see you as my girlfriend. Um, okay, so okay, I just noticed the quality is not so good. Okay. Okay, hold on. Did anyone understand that? Sorry, I had to put down my headphones and I didn't hear that properly. But is the audio quality okay? If so, I'll continue. Can you guys feedback in the chat just so I have some feedback, or else I'm going to go on and I'm not sure if you guys is everything okay? Can you hear me now? Is this good? Okay, can you hear me? I'm sorry, it's my first time on YouTube Live, so I find there's a lot of issues I wasn't expecting. I'm really sorry. I'm trying my best. Yeah. Okay. I, okay. So as I was explaining, the the integers. Okay. The variables can be assigned different types. I'm sorry. You have to understand, you guys. I can actually hear myself, but there's a bit of a delay. So if I try to put on the audio, if I try to monitor my own sound, it's going to get confusing for me because I hear myself like the delay of a couple of seconds. So you process multiple. Um, yeah. If everyone can hear me, I'll continue. Um, variables can be assigned multiple types. Okay, you have types of integer. You've got floats. There are strings, and we'll go more into detail later on. So just to show you here, all right, I am in these variables: Mark grade, John grade, Jeremy grade, right? And these are all type integer. Okay. Now normally when I try to in another language like C or C++, if I try to write this line and I print out the average, what's going to happen is that the decimal place is not going to carry over. What you're going to get here is a full number. What I'm trying to demonstrate in this line of code is that Python is smart enough to do typesetting for you. Okay. I'm not sure how it works. I know it can be quite difficult to understand because all these processes work in the background. They're quite optimized to sort of reduce the processing time as much as possible. That's just a smart way of saying that it takes the computer the least amount of time to complete this operation. But all you have to know is Python's smart enough to do this operation for you. Okay? As you can see here, it took these integers divided by 3 and returned a float. Okay, most languages don't do that, but which in my opinion makes it difficult to teach beginners. But in other words, Python is smart enough. So just to prove that this is a float, I do, for instance, try print get the exact command on. Yeah, if I do, for instance, okay, yeah, if I do, forget the okay, it's fine, don't worry about it. Oh, if I could do this, hold on. Type of average. Okay, yeah, that's that command. If I print this out, you can see it actually converts this to float. So just to prove to you, if I do, for instance, average is, I split this in 2 lines. So I do average equal to average divided by 3, and I print the type of average in the middle. You'll see it actually converts this from an integer to a float. Okay, don't worry about these commands. You don't have to learn them. I'm showing to you the different types. So I print this and okay. So see, it converted it from an integer to a float. It's smart enough to do that. Okay, so that concludes variables and types. Okay. Does anyone have any questions so far? I'm going to be monitoring the chat. Okay, if not, I'm going to be moving on. So this is show you this is variables. This is types. Okay. Okay. We're going to be moving now to operands. Now, operands is a fancy way of basically saying plus, minus, divide, multiply, etc. Okay. When you have multiple, we'll call them we call them values. Okay, we call these values. When you have multiple values together, you can actually use operand to manipulate one another. So that's not very clear, but basically, you have, for instance, you've got plus, minus, multiply, divide. Okay, I'll use something here. So let's say we have x equal to 10 and y is equal to 100, for instance. Okay, so we have okay. So if I do this multiple times, we got plus, we've got minus, we've got times, divide. We've got a special one. I'm going to be talking about modulo. Okay, and then there's also other ones, like for instance, double star, which is exponentiation. Don't get worried on the time; it's not that important. And then you have double division, I like to call it. If there's a few, I think there's also Boolean expressions. I'm not going to go into that, but yeah. So just to show you what's going to happen, let's push this. Okay. Okay, I'm going to print this. I'm going to change this from one to X. Oh, change this to X. 9. Okay, let's see what happens. I'm going to run this, and you get those. You get the results. So, for instance, X plus Y is equal to 19. Exactly. I want to focus on modulo. So, modulo is a very interesting operation. Basically, what it means is that let's say I'm doing long division. Okay, doing long division. Okay, and normally what I would take is, since I'm doing x divided by y, I would do, for instance, y, okay, and the long division thing with x on top. Okay, so I'm basically saying how many times x goes into y. Now, the modulo is the remainder. Okay, so if I'm not looking at the if I'm not looking at the actual division, if I'm not looking to divide into decimal places, I can actually take the remainder. So an application of this would be, for instance, how many minutes? How many minutes in hold on. What is the time? The time after 467 minutes, for instance, okay? So here, in modulo, we are calculating the minutes. Double division is similar. It's the other way around. Instead of calculating the remainder, we're calculating the actual number itself, right? We're discounting the remainder. We're calculating the number of hours. Okay? Exponentiation, this thing, we are looking at the power. Okay? So this is like saying x to the power of y. Okay? And those are operands in a nutshell. Now, does everyone understand so far? Okay? Everyone understands. Okay. If not, just text the group. Since I have my phone beside me, just text the group if you guys have any questions. If not, we're going to be moving on to the next topic. The next topic would be how do we? The next topic would be true false statements. Okay. So all right. So now we're going to be doing true and false statements. Okay. The beauty about Python is that so there are two values in Python. There's for instance, there's the value true. You notice that false and I have false. what true and false mean is exactly what it implies. It means that this particular statement is true or this statement is false. Okay. You don't have to worry too much about it. This is another type, what's known as a Boolean. Okay. Booleans are basically very, very, very short numbers. All right. So there's only two possible numbers that can be a Boolean. It's from 0 to 1. Okay. I'm not going to go too much into that, but just true and false, actual thing in programming. Now you can actually take variables and you can take numbers and you can actually turn them into some kind of truth statement. Okay. We call this another word is truth statement. Okay. Now, for instance, if I have, so there's a few expressions. I have like double equals. So we'll just go equal to 10. Y is equal to, what would you say? Okay. So there's double equal. All right. That means one side of the equation equals the other. See, right now, before when you're talking about this equal here, these equals are assignments. So we're taking the bucket y and we're assigning it the value 20. Okay, here. So we're taking the bucket marked red and we're assigning it the value 25. Here we're checking whether both sides are equal. So this is closer to the algebra equals you're used to. Okay, except it can't be too complicated. All right, I'm going to go into that later on. So you have double equals. You've got the not equals, if I'm not mistaken, like this. Okay. You've got greater than. So greater than would be this. You've got less than. And you've got greater than or equals to, and less than or equals to. Okay? Okay. If I print this, all right, you see some of these return false. So I'm gonna simplify the whole thing, make it x and y, and I'm gonna say this is x, 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 y, 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 y. I'll pass you the notebook afterwards. You can go back and play around with these values. Okay. So now I can change them around. By the way, what I'm doing here is I'm creating what's known as I'm dynamically programming these values. What that means is that you notice before I had all ones on the x's and all the other ones on the y's. What I'm doing here is I'm making the thing variable, so you only have to change one value and it will change all of these values down here. That's one application of a variable. That's what we do in programming. So it makes it easier so you can test this case. You can see that in the case where x is equal to 4 and y is equal to 1, right? They do not equal each other. They are not equal to each other. That makes sense. There's another expression as well. There's the not, right? Not. Okay? Not basically takes that true or false and inverses it. All right. So if a statement is true, and you write, for instance, I'm just going to take the last one. So if I write not x is less than y, right? What it does is it takes this statement and just turns it on its head, right? So I do that. You see how I have false x is less than or equal to y, but it is not. It's this statement is the not of this statement. It takes this result and inverts it. Okay. Okay, that's fine. So these are what we call truth statements. Okay. Okay. Does everyone understand so far? I might be going a bit fast. Does everyone understand? I'm hearing like my voice is going double on my side. I just want to check, is this the same as yours? Okay, that's good. So anyway, I'll continue. Those are truth statements. Okay, I'm gonna move on now to the next topic, which is if-else statements. So and if so, you probably know them as conditionals. I don't like to call them conditionals. I think because conditionals actually means something completely different in other languages. So I like to call it if-else statements. Okay. So in a perfect world, when you have a computer program, it will execute by line one. So I'll just do a simple thing here. You'll execute line one, then line two, then three, then four, then five, and you keep going until you reach the end of the program. Okay. Now the problem with this approach is that although we used to use it in assembly code way back in the day when we basically used to program at a very low level language. We talk directly to the CPU. We found that it was not high. It was not at a high enough level to do very complicated things to the program. Oftentimes, when you put it in assembly, it used to take like 2 or 3 times the amount of code compared to like a conventional language you are familiar with today, such as Python, C++, etc. So what happened was we actually found a way to abstract the concept of executing certain blocks of code at once to have what we know as control flow. Okay, if you guys are free, you can look at these terms. Right, the term is control flow. What this means is, let's say you have a choice you have to make. You're programming an application that has to make a choice based on the data it has in front of you. Right? Let's say x is equal to 5. Okay. And I'm going to be writing this in plain English so you guys can understand. So we say x is equal to 5, okay? And if x is greater than, for instance, 0, okay, we want to execute this code, followed, and then finally, then execute this line of code. I'm going to abstract. I'm not going to use Python syntax because I feel it can be confusing to a beginner. I'm going to use C. Okay. So sorry, not C. I'm going to be using known as pseudocode. Okay. I'm just going to show you what happens. So, let's say x is greater than 0. Okay. If x is greater than 0, and I want to execute this block. Okay. Execute everything in this block of code. Right. These are curly brackets. Right. In other languages, we use these to denote a block of code. Okay. So if x is greater than 0, we execute this code. Okay. If x is not greater than 0, okay, this entire block of code is not used. It's not executed. We jump straight to the end. Okay. So in a way, an if statement is a way you can actually control what lines of code and applications to execute. Okay. So just to summarize, so we went here in the early days of computing. We executed line 1, followed by line 2, followed by line 3, followed by line 4. So execute line 1, followed by line 2, followed by line 3, and so on. Okay? And we took this concept, this early adoption of programming, and we abstracted. Abstraction in programming means we take something that's very low level, that's very simple, and we take it out of its shell. So an example of abstraction would be like to use a calculator, all right, a normal calculator, like something you input your finances in, right? You don't actually need to know how the calculator works to be able to use it. You just need to have the interface and know how to use the interface to use it. So it'd be like Python. Python, you only need to know how to write the syntax how to write the program. You don't need to worry about how the program is executed, right? How the Python code gets compiled into machine learning, all these advanced things, you don't need to worry about it. So that is abstraction. We abstract the concept out. So another example of abstraction would be like if you write a program that calculates stocks, okay? And you provide an interface, right? You say, oh, okay, I have these stocks and I've had it from this day to this day, okay? And it returns into the value. So that's an abstraction. If you get confused, don't worry about it. It is an advanced topic. Just focus on me. So, okay. So anyway, these are if statements, right? So in Python, we write if statements. We say x is equal to 5, and if x greater than 0, okay, we're converting the pseudocode into actual code. X is greater than 0, all right? Print x, okay? Right? Then print done x, okay? So in this case, what happens here is the computer will look at this, right? Set the x variable to 5. Remember this statement here. This statement going back to here, it will convert this statement into either true or false. Okay. Then what happens is, if this is true, right? If this gets translated to true, it will execute this block of code. All right. If not, if it's evaluated as false, it omits this block of code. It immediately goes to the following block of code. Okay. So an if statement, you can think of it as, do I want to run this code? If not, then it will be omitted. Okay. You guys understand so far? Just please, I'm trying to check the chats regularly. Just please let me know if you guys are lost in any way. Okay. So okay. So the if statements we went through. Now, the if statements are great. The problem is we don't have ways to say, okay, I want to execute. Maybe when this equation returns false, right? Maybe I can do something like this. If x is less than 0, right? I want to do something else. Execute something else. The problem with this way is that you're evaluating the statement of, okay, this is wrong. Let's use what we learned. So, not x less than 0. Sorry. I just want, like I mentioned before, not basically, for those joining us, not basically take any of these statements and turns it and returns the inverse. So, for instance, if it's true, it returns false. False, it returns true. Okay, just like the bottom example here. Anyway, so we have here 2 blocks of code. So we say that if x is greater than 0, we print this statement. Or else, if x is not greater than 0, then we print something else. But this is quite tedious. You have to write a lot of code. So again, we use this term again. We abstracted this concept, right, into a new statement. We call it else. Okay. So just to prove to you, I'm going to run this. Okay. Done executing. Let's say in this case, x was evaluated as greater than 0. Let's say if I put something else, like for instance -2, and you see it executes something else. Okay. I can abstract the whole concept. Abstract is basically writing things in a simple way, and I use the term else. Just shift and enter. You see it responds exactly the same way. Okay. Now, this is great, and actually you can do a lot of stuff here. But let's say you want more control flow. Okay. You want to be able to do more things. You want to cater for different cases, and you don't want to keep rechecking statements. All right. You can use, so if you say x is greater than 0, else, let's say I'm taking another statement. Let's say I'm saying x is equal to, for instance, -2. -2. All right. So I say in the else, I say if x is greater than, equal to -2 or less less than -10, right? For instance, else this statement, right? It's very interesting. So you have a if statement, an if else statement, and tell you an if else statement. But it can get quite confusing. Already you're looking at this and you're wondering, is there a simpler way of doing things? And there is a simple way. So you notice you have this if, else if, okay, else if, you can say else if, all right? And that is abstracting it another level. Okay, so I better write this in a better way. So okay, I'm gonna write several versions of this. Hold on. So we started with version 1. Okay, so this is version 1. Okay. So this gets abstracted to this is abstracted to else. Okay. Then you have this statement. This is version 1 again. And this is abstracted to elif. Okay. So you notice that this looks a lot cleaner than this because you're not repeating this statement. And this looks a lot cleaner than this because you don't have to use a nested if statement. Okay? And if I run this, you can see everything is good. Okay? So that is if else statements. Okay? Does anyone have any questions at the moment? Okay, I'm just checking now. Please, the great thing about YouTube Live is you can actually write comments on here. I can check it periodically. The whole point of a live session is I can interact with you guys in case you don't understand. I can repeat material. I don't have to wait. You don't have to suffer in silence, basically. And if you're embarrassed, you can always PM me directly. I check my phone as well. Okay. So those are if else statements. So if we understand that, let's move on to the next topic. The next topic I want to talk about is a while loop. Okay. So this is a while loop. Okay. So a while loop, we take what we already know. A while loop essentially is a block of code that repeats itself over and over and over again, but it will check kind of condition. All right. So for instance, if I say x is equal to 5, that's means while x is less than 20, I want to print x is currently that number. Then print done. If I execute this program, oh, okay. This is interesting. I made a mistake here. You notice that it executes this over and over and over again. I'm sorry, let me. Okay, if you get to a position like this, basically I executed this code by mistake. You notice that it's running a start, which means the code hasn't been finished executing. If you get into this position, you click on kernel and you click on interrupt. Okay, let's change this. Let's say x is equal to x1. All right, and I run this, and okay, this works. So what happens here is that it will assign the value of x, assign value of x, okay? It checks this statement first, all right? So it will check whether x is less than 20, right? And if it's less than 20, remember it's like an if statement, right? If it changes to an if, it basically goes inside the block, right? But because it's a while, what happens is, once you get to the end of the block, it will check the statement again, right? So gets to the end of the block, goes back to we'll call this line A. Goes back to line A. Then it checks this. So we have x there. We've reassigned it x, which is evaluated as 5 plus 1, which is equal to 6. So we find x, the value 6, and then we check 6 is less than 20. Not it goes on again. So now, so the 6 becomes 7, becomes 8, 9, 10, 11, 12, all the way up to 19. Notice how it does not print 20, because 20 is not less than 20. So it will, if it checks this statement here and it returns false, okay, then it's done. Now, okay, does everyone understand that so far? Okay. Yeah. So, okay, there is a different way of doing things. So this is a conventional while loop. Okay. There's another way you can write a while loop. It's a bit advanced, but it can get quite useful, and you'll probably see it. Now, let's say I have x equal to 5, again, and y is equal to 15, for instance. Okay? I can say while true, okay, while true. So I'm doing something quite interesting here. While true, if this evaluates to true, it just repeats the line over and over again. Okay, I say x is equal to x plus 1. Oh, sorry. Let's print the values of x. X turns x, and we do y is currently y. Okay, and let's increment both of them by 1. So x is equal to x plus 1, and y is equal to y plus 1. All right, now we're doing something special. Let's do an if statement, okay? If, right, x is equal to 1, or y is equal to, say, if x is greater than 50, or y is greater than 50, okay? We're gonna try one. We're gonna call it break. Okay. So what happens here? By the way, I didn't explain this before. I will explain it later. Just be patient. Okay. What happens here is evaluating is x greater than 50. All right. Then we're evaluating is y greater than 50. And if either of these conditions is true, what happens here is that this whole while loop will break. Okay. This block of code. What happens here is that this code will discontinue. Okay, so what we're doing here is this is jumping to the end to the next block. Correct. The next block, or to line B. Okay, so this is line B. Okay, line. Okay, so if x is greater than 50 or y is greater than 50, right, we break the statement, go to line B. What if you have multiple nested while loops? I'll let you guys figure that out. That gets quite complicated. I'm not going to teach you that, but this will be quite useful sometimes when you're writing a program. If you are confused, don't worry about it. This is a bit of extra material, okay? There's also another one called continue. So in continue, right, let's say if x is modulo 2 is equal to 0, all right? We're going to do continue. Okay? What this continue means is that instead of this so what happens here is hold on, spend this as simple as possible. We print not continued. Okay, what this continue basically means is regardless of where you are in the block, go back to the top of the block, check the statement again, and then go back. So to explain it in a layman's way, right? assigning value of 5 to x, value of 15y. Okay, but then checking whether true is equal to true, which it always will. Okay, print x and print y, increment by 1. Okay, and then now we're checking whether x is greater than 50 or y is greater than 50. Okay, break, we go to line B. Continue, we'll call this line B. We'll call this line B. And we go to line C. And here we're jumping to line B. So breaks from the current block of code. Continue, starts from the top. Okay? It's quite a complicated topic. If you don't understand it, it's okay. Just stick to the conventional while loop. Okay? This is advanced, more advanced while loop. Okay? So don't worry about it if you don't understand. Okay? So that's while loops. Right? We're gonna be everyone good so far? Does anyone have any other questions? If not, we're going to be going to for loops now. So for loops in most languages are very similar to while loop. And the way you structure a while loop is, you notice here, I declare the variable x, in the convention, ignore this. You notice in this while loop, I declared the variable x, I put some kind of condition, and I added 1 to it. In most languages, we follow this convention. Python is a bit strange because, again, it's abstract. Okay, it's higher level than most languages. So for loop, a for loop in Python, if you know the term, if not, don't worry about it. It's always a for in loop. Okay. Don't worry about and and or. I'll cover that later. Just because I'm on a roll. Okay, so a for loop in Python is always a for in loop. What this means is that, hold on. Think. Okay, sorry, no. Okay, let's come back to for loops. Okay, I'm going to explain a few other concepts. Okay, sorry about that. So, okay, let's move on to or here. Okay. By the way, to create a new cell, you just go to. I'm going to go back to the phrase. I'm going to create a cell after this. So I'm going to go cell insert below, and I go cell. So we're going to be talking about and or not. We already covered not. I'm going to cover and or. So and is essentially just to have true. We'll say x is equal to true, and y is equal to false. So and is essentially if x and y, right? If both these conditions are true, it's going to print true. Or is if either of these conditions are true, it's going to print true. So this should be false. This should print true. Okay. X and y. X or y. Okay. So just to show you. Okay. Yeah. You can see here. X and y in a nutshell. Okay, so that's a very simple. I should have explained it here. I'm really sorry. I forgot to mention. So that is and or. It's very similar to not. It's just it's checking multiple conditions. So you can actually string these together. You can say print x and x or y. Okay, this is a valid Okay, and this is valid. You can also it's true because I'm testing X or X, so this is always going to be true or Y. So you can string it together from left to right. You can also you can also do this. So if X or Y, okay, and this is valid as well. So it's true. You can play around with these. I'm gonna focus on. Okay. Again, I'm sorry I didn't mention this earlier. I was quite distracted. Okay, so there's a boolean. So yeah, these are we'll call these and or. Okay, I'm going to move on to the next topic, which is I'm going to move on to lists and dictionary. First, list. So, what is a list? So, lists. So, a list, you can think of a list as like shopping. Okay, so let's say I'm going to the grocery shop and I want to buy some groceries. I'll say I want eggs, I want milk, and I want some bread. Okay, this is a list in real life, all right? This would be like list in real life. In Python, we can actually write lists as well in a similar way. So you notice how I have two elements to this list. I've got the actual values that I want to get, and I've also got these. We call these index. Okay, so this is index 1, index 2, index 3. Python is a bit weird because it doesn't start with index 1, it starts with index 0. Okay? It's exactly the same. This list is exactly the same as this list. Instead of starting with 1, I'm starting with 0. Okay? And so yes, that is a list. So the way you declare a list, so I say my shopping list, and I can create it as eggs, milk, and bread. Okay. Notice I don't have to write the indexes. The indexes get assigned for me. Okay. If I print my shopping list, okay, I get this. So it doesn't show the indexes here, but you have eggs, milk, and bread, for instance. Okay. Dictionaries, I like lists. Instead, dictionaries. The thing about dictionaries is instead of saying 0 eggs, blah blah blah, right? Instead of an index 0, I'm using an actual value. I'm using an actual string. So instead of eggs, I could say, for instance, breakfast, right? Breakfast, breakfast egg. I don't know. I'm just not sure what a good example was, but I use breakfast eggs. Okay, let's say I use beverage milk. Okay, and bread I use substitute, right? All right. So it's exactly the same as the list, except instead of using indexes as numbers, we're using the description. Okay. So in this case, right, my shopping dictionary, right, in this case would be curly brackets, press enter. Okay. Breakfast, eggs. Okay. Beverage, milk, substance. I don't know how to spell substance, so you have to forgive me. Bread. Okay. Notice you have to write a lot more. So whereas in a list, right, Python will automatically bind the index for you. In a dictionary, you have to give your own indexes. Actually, we don't call these indexes anymore. In a dictionary, we call these either attribute or key. Okay. For this class, I'm going to use the term key. So this dictionary has 3 keys. We have breakfast, we have beverage, and we have substance. And if I were to select a list, if I were to select, for instance, print my shopping list 0, for instance, right? And if I were to print my shopping list, my shopping dictionary, and I would have print, for instance, beverage. Okay, you get completely different answers. Okay, so just a different way to reference a list of items. Okay, now if any of you are observant enough, you notice there are some similar. There is. I wasn't completely truthful. Dictionaries lists have a few more extra sort of functions to them. All right, a few more abilities that Python has with lists. Now, the thing about lists is that there are numbers here. You notice you have 1, 2, 3, etc. The great thing about lists is that Python has full control over the index, and depending on what you want to do, right? Python has the ability, it can find, for instance, the sum of the list. Can't do that with a dictionary because it doesn't know how to index it. Don't worry about this. I'm just letting you know. So with dictionaries, purely descriptive. With lists, right? Python has more function, has more control over that particular list. So let's move on to the next topic, which is what I was getting on earlier, which is for loops. Okay. So for loops in Python are not like while loops. All right. In other languages, for loops are based on while loops. But because we're using Python, for loops have their own particular quirks in Python. In Python, the way we do for loops is we always go through a list. Okay? Always a list or a range. This for the purpose of this class, right? We'll assume it's incorrect, but we'll assume that this are the same as ranges. All right? Okay, so for instance, we will assume lists are ranges. What is a range? A range is simply when you type in a function range and you have 50 things, right? So this is a range from 0 to 50. You can think of this, not 50, like 5. You can think of this as the same as, okay, 0, 1, 2, 3, 4. We don't include 5. 5, remember, this is the number of items in the list. So this is 0, 1, 2, 3, 4. Okay? In a for loop, a typical for loop, we can have a statement like this. For x is equal to 10, right? For I in range 10, right? Print the current index is I. Okay? So in this case, we have a for loop. Okay? This I is just a variable we use to assign to each of the range. So you can think of this for loop as for every element in this list, right? We assign I as the current element. All right. So if let's say we were using this loop as an example, okay. I could start here. So in this case, like in this case, let's say I is equal 0, for instance, 0. Then I will start here in the beginning of the list. It will represent 0. Then after this loop is done once, it will move on to the next number. So now I is equal to 1, and then it moves on to the next number, and then I will, and etc. It'll keep going. It'll keep doing that until it gets to the end of the array. So let's demonstration is better. So let's run this code, and you can see that the current index starts at 0, and it keeps going all the way till 9. Okay. Now, going back to what I said, we can assume a range is the same as an array. So let's use this information. Let's have the array, the shopping list, right? The area. Let's copy that. Okay. And instead of I in range 10, we're going to say I in shopping list. Okay. I'll click enter, and you see instead of using 0, 1, 2, 3, 4, I now refers to this object first, x, followed by this object, followed by this object. So you can see I is moving through the items in the list. Okay? Okay. Does anyone have any questions at this point? This step is really crucial. If you can understand that for loops are basically values that you assign. This could be I, this could be any value. This could be A, this can be orange, this can be castle, right? It does not matter what you call this, as long as this value is the same. Okay? Exactly the same, right? This value, don't worry if it's I or J or syntax or whatever. This is just something you call. As a programmer, we just use variables such as I or J or K or L or M and N, right? All these variables all the way down to Z. We use them as what we call them as iterators. Okay, so iterators are just variables that change values all the time based on the current index. Okay, in this case, I'm just used to writing I. You guys can call this variable anything you want as long as you refer to it back down here. Now, even if you don't want to refer to the variable, that's also fine. So if I take this out and I just say print executing, right? This is also valid code. It just means you're not using the current index, but just for your information, we can refer to it or not refer to it. Okay? Okay. Just say so for loop cycles through each item in our list, and for loops do not necessarily, not spell today, do not have to use the variable castle. Okay. 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 Now, do you remember in a while loop we had these breaks to continue? In a for loop, it's exactly the same thing. You can still use break, you can still use continue. What a break does is it breaks from the for loop, it goes to the next line. What a continue does is it goes back to the first line, increments cancel by increments to the next element in a list, and it keeps going. Don't worry, this is advanced stuff. You don't need to worry about it. Okay. Let's move on to the next part. So, by the way, just to a bit of extra stuff. What if you want to reference this list, but you don't want to reference the actual item itself? You want to go back to the next one, you can do that too. With that, right, we have to use a property called length. Okay, so what length does is it returns the number of elements in the list. Okay, I do, for instance, print the length of my shopping list. Okay, you see here there are 3 items. So if you wanted to go by index, you can do for I in range length, then my shopping index. And this should be exactly the same as going to. So, for instance, index. So I'm going to do something special here. It's something to freak out. Percentage D. All right. Percentage S. Okay. Don't freak out. Just I'll explain this later. So, for this we do I. Okay. And do my shopping list of I. Okay, we execute this. And what this does, D refers to the integer, S refers to string. If you remember way back up here, I's have to be interpreted differently. Okay, so especially when we're printing something, right? The computer needs to know exactly what it's printing. So we say interpret I as an integer, interpret my shopping list as a string. If you don't understand this, don't worry about this. This is just extra stuff. By the way, I highly recommend, if you don't understand anything, either ask me directly or you can look all this stuff online. There's a lot of material based on this. Definitely, if you guys have a question, search me first. If not, there's definitely a lot of material that goes into a lot of detail. This is just extra material. Okay. Okay. So okay, let's move on to the next thing. So okay, so we covered a lot of stuff. Just to summarize, we covered variables, we covered types, we covered operands. All right, so plus, minus, multiply, divide, exponentiation, modulo. I call this double divide. I don't know what it's called. You have true, false statements. You have these and or expressions. So that just combines multiple statements together. You have conditionals, right? So if else statement, okay? And you can see that this is a simple. This is how this expression would be written if it wasn't. Actually, it's not quite like this. Python has more optimizations it takes between this and this. So these two expressions are not exactly the same in terms of operation, but they logically mean the same thing. Okay, and then you have these. The ellipse is basically this nested if statement. But again, it's just abstract. Abstraction is just a simplified way of writing. Okay, you then have while loops. Okay, and if you can understand this, kudos to you. It's just a break statement and a continue. All right, this basically it's all under the whole concept of what's known as flow. Okay, so this is how you control a program. All right. Okay. So, that's one thing. Okay, let's talk about okay, so this is a for loop. So now you're probably wondering, well, can you do a for loop on a dictionary? You can. So for loop in a dictionary. So for, we're using a different word this time. We're using key. I'm gonna say this is for loops for lists. So we're gonna start a new we're gonna say for loops for dictionaries, and this is very simple. This is just like a list, except when you do a for loop on a dictionary, instead of reading values, right, we're going to be reading the key. So we're going to be saying for, this is a new word, key. Exactly, it's just a variable. I'm naming it can be anything, castle, dogs. I'm going to name this key. Key. So key in, we're going to use my shopping dictionary, okay? My shopping dictionary, right on top. So key in my shopping dictionary, okay? We're going to print key is key, right? We're going to print this, and you can see we're reading the keys rather than the actual values themselves. Okay? To reference a key, instead of doing this, you can say key or key, value of, we're going to do the fancy thing again, percentage S, percentage S, okay? String and string, okay? Then percentage, so we use the key, and then my shopping dictionary, and key. Okay, hold on. Okay, like that. Okay, so you can see this is the key. So for the key, for value of key being here, this is the. Okay, so I can write a simple version if you guys are confused. Value key value of value my shopping dictionary key. Okay. Exactly this. Okay, if you guys don't understand, if you can understand this, if not, it's not important. It's just a shorthand. So you can see key. We'll just make this. We'll tidy this up a bit. We'll just add a extra space. Okay, and then you can see value of the key is breakfast, and eggs, beverage, milk, substance, bread. Okay, very very simple. It's exactly like this for loop list instead of, but the only difference is that instead of cycling through the values, we're cycling now through the keys. Okay, keys are exactly the same thing as indexes. Instead of being numbers, they're just values you write out in words. Okay, so that is. So how do you now? I did something here. I don't know if some of you have caught on. I used these square brackets to basically reference index. Okay, so in a dictionary. Sorry, I should have put this here. You notice we use the square brackets to tell you where in the list the computer should read, right? So this, you can think of this list as like a bucket with 3 values in it, right? You've got eggs, milk, bread. And this index tells you which item you want, right? So do you want the first item, do you want the 0th item, second item, the first item? Remember, with index 0. And then with each, it's instead of the 0th or the first or the second item, we say we want the breakfast item, right? The index. Okay, so I'm just going to write this down here. So reference list by, we can reference dictionaries by dictionary, and here we can reference we can reference list by list type. Okay. We're going to be doing problems on this later on, so don't worry too much about it. Okay. Okay. So there's a for loop and function going through a dictionary. So I think that pretty much covers classes 1 and 2, if I'm not mistaken. So now we're going to go into more advanced topics in arrays. So this should be the final section. Oh, sorry, not arrays, lists. Sorry. Advanced lists and dictionaries. Okay. A list. So lists you know as buckets of information, right? Say my list. I can say as 1, 5, 6, 7, 8, etc. All right. But you can write lists like this. You can even mix different types together using strings. This is valid. Not all languages, but in Python, this is actually valid. Okay. For this purpose, I only use strings. So yeah. Now you can actually reference different values in a string. So let's say I wanted the third item in this list. I can just say the third item in my list is my list 2. 2 because we're starting from index 0. Okay, we're starting from index 0, right? And this will return the value 7, okay, because it's the third index. All right. Now, the interesting thing about lists is that you can actually have lists inside of this. In fact, a list is the type, is treated as a type in Python. So you can have, for instance, my context list. And you can say this is 1, 2. You can say new list, right? 3, 2, 5. A new list 6 and 7, right? And all this means is that this particular list is treated just like any other element. Okay? To prove to you, right? I could just say print the third element. Okay, I'm just going to copy the whole thing. And you can say the third element in my complex list. Okay? And you actually get an array. Okay? Now, we know, a list. Arrays, the terms arrays and lists can be used interchangeably. There are some differences, but we don't worry about it. They're interchangeable, okay? So, because this is returning a list, what you can do is you can say, let's assign this Let's assign this to A. And assign this, I'm going to say A is equal to this particular expression. And now I can reference the third. Okay? I can do this. Okay? So you notice I'm referencing the third item. Okay? And now the interesting thing is this can actually be, again, we use that term again, we can say it's abstracted. Because now we say that x is equal to my complex 2. We're storing this value into A. We can now substitute it. And this holds true for any variable in any program, in any language, all right? They're completely swappable. You do something like this, and you get the same result, all right? And you can even do this, right? Okay? So, hold on. Try to, okay? These are interchangeable. Okay. So that covers lists. Now, dictionaries are exactly the same way. So with a dictionary, say I had my dictionary, We said books. Moby Dick, for instance. We can say book thief, and we can say location, Singapore. So this is complicated, but this is exactly the same concept up here. We have dictionaries within dictionaries. In fact, Moby Dick. So old. Okay, you have dictionaries within dictionaries. This is completely valid. Go to print my dictionary. Okay, you can see it prints out this as a dictionary within a dictionary. Now the interesting thing is, the way you actually call this, right? So you say new book is, you actually refer to it as dictionary. Okay, we learned this. So you go under books, okay, close the bracket, and then you can insert a new field. So in this case, we say new, okay, and you have this value. So exactly, this concept is exactly the same as this concept, except instead of using a list, we're using a dictionary, and you can see that the index is exactly the same, except instead of using an integer, we're using a string. Okay. You can also have mixed, right? So you can say my mixed. We'll just call this mixed, right? And we're going to do exactly the same dictionary. That we're not going to declare a dictionary. We're going to declare an array. And you can see here, this is also valid. Okay. So because lists and dictionaries are considered like types, you can do this. Now instead of doing this, we say 0, and this works. All right, it works. Okay, does everyone understand so far? Just checking the chat. Okay, so now that that's out of the way, so let's move on to even more advanced lists. Okay, so we're gonna call it for instance, super advanced list. Okay, let's say I have this list here. Let's say better still. Let's say I have a list So remember range. So I'm going to do something strange. I'm going to do list is equal to list, then range, then I'm going to say 100. Okay. This list basically means type setting. For the purpose of this lecture, we assume lists are ranges. I just have to be. I have to tell Python that to interpret it. So if I print list, you can see that there's hold on, my list. When you notice you're writing a variable, like let's say you have list and you see it's highlighted like this, that means this word is reserved. Do not use this word. Try to come up with a different word. My naming convention, what I do is, if I see the word is highlighted, I just add my in front of it. I'm thinking an easy way to basically name variables because no program is going to use no professionally produced programs are going to have this particular variable. So don't worry about it. Okay. Anyway, I'm going to print this now, and it calls an error. Okay, don't worry about this line. Just forget about it. Let's create a new list. Okay. All right. Forget about that line. It's not important. Okay. And then we print my list. Okay. Okay. So you can see it prints the list perfectly, expected, right? Now the interesting thing is, Python has a way of slicing arrays that are built natively. Now, usually in another language, you have to call some library or some method. A method or library is just something, an external program we call to basically process some stuff. Okay, we're not covering functions here. This class we're going to be covering another time. So, in Python, you can natively splice arrays. So what splicing an array means is I don't want the entire list. I want to start from a certain number, and I want to end to a certain number, but I don't want to put all the numbers in the middle. I want to jump. So I want to go from 3 to 5 to 7. Okay? Python has a way of doing it. And the way it does it is with the square bracket. Remember? So if I do my list, if I print for instance, the fifth element of my list, so the fifth element is 4 because the first index is always 0. We calculate this, or I'll just add comments. So my list is, and the fourth element of my list is, okay, the fifth element, mistake, it works, all right? You can see here, it says 4. We expected, this was already covered before. But you can do something really weird. You can do, for instance, right, the fifth to the seventh element of my list, and it goes from 4 to 6. Okay? The fourth element, the fifth element, to the seventh element. Okay, hold on. Fifth to the seventh. Okay, hold on. Give me a second. Just check. Okay, yeah. Sorry, I made the mistake. This is the mistake I made up. Okay, it's the n plus 1. All right. Sorry about that. My mistake. So 7 elements be 8. Okay. So you can see we go from the fifth element. So in this case, that's actually 5. Okay. We go from the fifth element, then 6, then 7, then this is a bit bizarre. The syntax, you will get used to it. Sorry. Oh yeah, okay, my mistake. So it is actually 4. Right. Okay. Right before. I made a mistake. Fine. Start this up with 1. Then future. Yeah. So we go from the fifth element to the seventh element. You can see it's 5, 6, 7. Right? So this is the starting index, okay, and the end index plus 1. So we say that this square notation, right? So my list, if you say the start existing index, right? The nth index plus 1. Okay? But there's another one as well. We can do steps. For instance, okay, let's do another one. Let's say I want to print all the odd elements. So the odd elements. Okay. The way we do that is we do 1. We omit this field. We're not specifying an end, and we do 2. Okay? And this should work. Oops, hold on. Oh yeah, odd. Sorry. So we go to 0. 2. Because this is 0, we can omit this as well. Okay, the omitted fields here. All it means is that it always defaults to these values 0 and -1. -1 just means instead of counting from the beginning, it counts from the end. Okay? It's a quirky thing Python used to be. If you don't understand it, don't worry. You can always just do the normal way of doing things, right? So the colon 2, we have this step. So just to recap, so in this case, end, and then we have the step. Okay. So how many steps is it supposed to go into? And we can change this. We can say we can put random values here, right? You can say you can get creative, right? You can say like 13, you know. There's no syntax. Okay. Yeah. You can calculate this later on. Like for instance here, 6, this number, then you can see that these are the. So when it slices a list, it doesn't depend on the value. It depends on the index. The value can be anything. Okay. Okay. So just to recap, so if you default, okay, don't worry about the empty index. Just focus on the empty index is the -1. Don't worry about it. So I'll just what I'll do is I'll just start the 0, and then I'll say the length of my list is -1. Length of my list. Okay, so it gives me the same thing. Okay. Does anyone have any questions so far? Is everything good? Let's check the chat. Okay, so that's like a super advanced list, so don't worry about it if you don't understand it. Other than that, I've already gone through everything. Okay, I'm just gonna check the chat. Things are on. Okay, and that concludes the lesson. Okay, I'm just going to post some questions underneath, extra questions for you to try at home, just get the gist of it. So, hold on, let me just post, I prepared some questions. These are the questions, all right? Some of them you'll recognize from the presentation, others are own sort of questions. You can try them out to familiar yourself with the concept, but I think we're caught up to the lesson. So hopefully this was useful. If not, I'm always available to help out. So, okay. By the way, to write, okay, one last thing, to write comments is, as you noted, it's the hash symbol. These kind of like multi-line comments. Actually, this is a multi-line. It's known as a multi-line string. So these are exactly as strings, but because I'm not assigning it to anything, this is actually how you write multi-line comments in Python. There's no interface to do otherwise. If you have any questions, my number is or you can contact me on Telegram. I hope you don't mind. This is a public forum, so I don't want to. I don't want to have random people calling me. That's not pertaining to this particular class. Does anyone have any questions? If so, I'm going to end the seminar. Thank you all for joining. I'm going to stick around like 5 or 10 minutes observing a chat if anyone needs any help. I really apologize if I was late. I was trying to figure out how use YouTube Live, and I do regret using it a bit. At the time, I had some problems with connecting. Okay, I hope this was useful. Really good. I'm gonna leave this online, so you guys can ask me questions if you want. Okay, gonna mute the microphone now. Okay. I don't think anyone has any questions. So I'm gonna sign off now. If you guys have any questions, you can just PM me directly, and happy to take your questions, concerns. All right. Good night. Signing off.